Hey, good afternoon, class, and welcome to Day 3, Lesson 1.1.5 of Precalculus, where we are going to use some problem-solving skills to answer word problem questions. Before we do that, here is a short warm-up. So let's take a look at one or two of the problems before you pause this and work on it on your own. So number 1, you have the square root of 12. We want you to simplify this radical. Now, there's a couple of different ways to do it. I think one of the best ways to do it is to take a look at 12 as 4 times 3. So I can rewrite this as the square root of 4 times 3. And the square root of 4 is 2 times the square root of 3. Now, another way to look at it that some of your teachers may have done is to build a factor tree. 12 is 4 times 3, 4 is 2 times 2. Since I'm looking for the square root of 12, cross off your factors in pairs, write one down, and whatever you do not cross off goes underneath the radical sign. You can use either method. They both basically are doing the same thing. It's just the factor tree is a little bit more visual. And what if you get to more complicated ones, like number 9? You have 2 times the square root of 98. So let's use that factor tree on 98. Well, 98, that's 49 times 2. 49, that's 7 times 7. So I'm going to cross off that pair of 7s, write one down, and what I don't cross off was underneath the square root. And 2 times 7 is 14. So once you pause this and do about 5 or 6 of these, do 2 or 3 from the top, maybe 1 or 2 from the middle, and a couple from the bottom. All right, welcome back. Please take a look at these answers. You may want to pause it so that you can reflect on some of the work that was shown. I did not use a factor tree. What I did is I looked for the largest prime factor that goes into each of the values under the radical sign. On to the next slide. Today's lesson is about setting up and solving word problems. So what we're going to do is just talk a little bit about some of the strategies that you can use, and then in another slide or two from here, you'll be asked to repeat these. Some skills that you've used in the past when setting up word problems. One is to use let statements. 2, draw a picture. 3, write an equation. 4, highlight information. Number 5, ask a teacher. Oh, just kidding on that one. But you can still use that. But it's not one that you're going to be able to use when you're necessarily by yourself trying to solve this or with a group of people. As you're solving these problems, we highly encourage you to work with others. Set up a Zoom session, you all have that capability, or get together at a coffee shop or someplace and try to solve these, set these problems up. There are a couple of key concepts that we're going to focus in on, or types of problems that we're going to focus in on during the day. There we go. First question. Farmer Ginzal has 300 feet of fencing to enclose 2 identical rectangular pens that share a common fence. Well, let's use some of our problem-solving strategies. Let's highlight some information. 300 feet of fence. 2 identical rectangular pens that share a common fence. Okay, well, let's do another problem-solving strategy. Let's draw a picture. So there's one rectangular looking fence. There's a second rectangular looking fence. And let's let x equal the width of one rectangular fence. X, 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 X. Okay, so we have 300 feet of fencing. We're going to use X there, X there, X there, and X there. So what's left over for the other sides? Let's let Y equal the other sides. Y, Y, Y. So we know that the x's plus the y's have to equal 300. So 4x plus 3y must equal 300 feet of fencing. Ooh, another problem solving skills. Write an equation of what we know. But we want to now, let's see, what have we got? Answer this question. What are the dimensions of the pens? Oh, so we're kind of along those lines. What are the dimensions of the pens that make their areas as large as possible? Well, this is all perimeter stuff. Yeah, I should write that a little bit better. See if I can squeeze that in. So area, well, the area of the entire region is going to be y times 2x. So I've got two equations with actually three variables because we don't know the area. Let's see if we can simplify this down into two equations with two variables. Let's take the perimeter equation and let's get y by itself. So I'm going to subtract 4x from both sides. So that means 3y equals 300 minus 4x. Now I'm going to divide both sides by 3. So y equals 300 divided by 3 is 100 minus 4 divided by 3 is 4/3 x. Let's plug this value, or this equation, which is equal to y, in here. And we get the area has to equal 100 minus 4/3 x times 2x. Now if I try to figure out what would this look like, sorry about that, I had to do a quick readjustment. What would this look like? I've got area and I've got these two factors. Well, you've done some work like this before. Back in Algebra 2, you were graphing parabolas that looked like this, but they were more in the form of, you'd have y equaling x plus 2 times x minus 3 or something like that. Well, we're going to kind of do the same thing. We're going to say that we've got this parabola, A equaling 100 minus 4/3 x times 2x. And that sketch here's x, here's our area, is going to look something like this, where our x-intercepts occur when the area is equal to 0. So I'm going to take 0, and I'm going to set that equal to 100 minus 4/3 x times 2x. Use your zero product property. 100 minus 4/3 x has to equal 0, or 2x has to equal 0. Now I'm going to solve for x. Divide both sides by 2 in the one equation, x equals 0. Subtract 100 from both sides, and then divide by a negative 4/3. X comes out to 75. So I have an x-intercept at 0, 0, and another x-intercept at 75, 0. Well, if this is parabolic in shape, then this output value has to represent the max, and x must be halfway in between 0 and 75. So at 37.5, I'm going to get my maximum area for the two rectangles. So let's take 37.5, plug it in for x, and figure out what the maximum area is. Area equals 100 minus 4/3 times 37.5 times 2 times 37.5. This area happens to be 3,750. Now we feet squared. Now we found the maximum area. You didn't need to do that, but I was just kind of curious. I mean, that's kind of what we're trying to do. What we really want to find now are the dimensions. Well, we already found that the x value that gives us the maximum area is 37.5. So that means if I take and plug that into this equation over here, I can find y. So if I use the perimeter equation, four times 37.5 plus 3y equals 300. 4 times 37.5 is 150, plus 3y equaling 300. Subtract 150 from both sides, divide by 3, and y equals 50 feet. When x was equal to 37.5 feet. So our dimensions are x equaling 37.5 feet by 50 feet. And that's kind of the main emphasis. What we want you to get out of this is, can you find the measurements that will give us the maximum area, and then find the maximum area. So let's try another one. Go on to the next slide. Well, first of all, let's backtrack 1 minute. What strategies did you use, or did we use to solve this? I want you to pause this and write down strategies that you think were useful in solving this problem. And then after you're done with that, push play and we'll see what I wrote down. All right, welcome back. I think these are the same 4 that we wrote down on a couple of slides ago. So draw a picture. We did that, and we use a let statement or 2. Write an equation. We did that, and highlight. So I think we kind of covered them all. If there's other problem-solving strategies that you used, feel free to add those to the list. Next slide. Now here's another one. Farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? Okay, so again, we're going to highlight 2,400 feet of fencing. A rectangular field that borders a straight river, no fencing along the river. What are the dimensions that has the largest area? Now we're also going to find that largest area. But let's draw a picture. So start with some blue water right there. And now let's draw some fencing. Look, I think we're only going to have 3 sides to this. Let's let X equal the left and right side. Let's let Y equal the long side. Now what I'd like you to do is pause this and see if you can write an equation for the perimeter using X and Y, and then an equation for the area. Now the area is going to equal something in terms of X and Y. Go ahead and pause it and see if you can write those. Okay, welcome back. Here's what you should have come up with for the perimeter and area equations. Our perimeter, we have 2,400 feet of fencing to use. And we're going to use it on 2 X's and a Y. So 2X plus Y equals 2,400. The area is X times Y. Now at this point, I'm going to have you pause this, and I want you to put those 2 equations together so that you can maximize the area. And there's another part to it. Sketch a picture that goes along with this parabolic shape. So pause this and then come back when you're done with those 2 things. Okay, welcome back. Here's my picture along the horizontal, here's my equation for area first. I took the perimeter equation, got Y by itself, which was then equal to 2,400 minus 2X. I then plugged that into the area equation. So area equals X times 2,400 minus 2X. Since that's going to be a parabola, I'm going to use that zero product property, the ZPP, set X and 2,400 minus 2X equal to 0. Or excuse me, let me rephrase that. X times 2,400 minus 2X equal to 0. Then by the zero product property, X has to be 0, or 2,400 minus 2X has to be 0. That will give us the x-intercepts for this area parabola. And so now I sketched that parabola. On the horizontal axis, I got x. On the vertical axis, I have area. And my 2 x-intercepts were 0, 0, and 1,200, 0. Therefore, the max area has to be right in the middle. It has to be when x is 600. Then my max area is when x is 600. So I'm going to go 600 times 2400 minus 2 times 600. And that comes out to be 720,000 square feet. We still haven't answered the question completely. We also need to find the other dimension. Well, if x is 600, let's do this visually, 600, 600, and my total feet of fencing is 2,400, then y has to equal 2,400 minus 2 times, oh, this is just one of those factors. And so y comes out to be 1,200 feet and 600 feet. All right, there's another problem or two that we're going to have you do. Now this deals with an open box. In your homework assignments over the course of the next month or two, you're going to see a couple of these. So let's try to develop these skills also. What I would like you to do is pause this, highlight the information that you think is important, draw yourself a picture, and just, if you can write a let statement, do that. See what you can come up with without me showing you. Sometimes getting started is the most challenging part, but I know you can do this. So pause it and try starting the problem yourself. Okay, welcome back. This is kind of maybe some of the stuff that you're able to get written down. You're able to draw a picture, do a let statement or two, and write an equation. And so I let h be the height and x be the width, and then 2x would be the other side of the base. And the volume of 4,500 must equal length times width times height, or 2x squared times h. Now, where is my other equation? Well, that comes from the question being highlighted in red that says surface area. So my surface area is the sum of the 5 sides, because remember, the top is open. The base is x by 2x, plus the front is x times h. The back is x times h, because there's 2 of those. The right side is 2x times h. And the left side is 2x times h. So if I put all this together, the surface area equals 2x squared. That's the area of the bottom. And then I got a 1hx, another hx, 2hx, and 2hx for a total of 6hx. I'm going to replace this h with this h. So I need to get h by itself in the volume formula. So I'm going to divide both sides by 2x squared. And h equals 4,500 divided by 2x squared. And that is going to go in for h. So surface area equals 2x squared plus 6x times 4,500 over 2x squared. If I simplify that, surface area equals 2x squared plus 6 divided by 2 is 3. 3 times 4,500 is 13,500. And one of the x's in the denominator cancels with the x in the numerator. Now this equation is a little bit more complicated than the ones that we used before, and we could make parabolas out of them. So I want you to go to your graphing calculator, graph this, choose a window that's going to help you find the minimum surface area required and the corresponding x value for that. I'm going to do the same thing, and we'll be back here in just a bit. Okay, so there's a picture of the graph. It takes a little bit of time to play around with that window to get it to fit just right. But you can see that when x is 15, our minimum surface area is going to be 1,315. So let's write that down. This is centimeters. The surface area is 1,350 centimeters squared. But I still need to find the other dimension to find the height. Well, we've got this equation in green, where if I plug x in there, I can find the height. And I know that the third dimension then is 2 times x. So h is going to be 4,500 divided by 15 squared times 2, which is 450. So h comes out to be 100 centimeters. X was 15 centimeters, and 2x is 30 centimeters. And let me take that back. It's not 100, it's 10 centimeters. Maybe I should do my division a little bit more carefully. All right, I think that's all we're going to do. We're not going to do the last problem just because of the length of this video. Hopefully you enjoyed it. You've developed some skills. Please use your problem-solving skills to help get these things set up and work with others. Have yourself a great afternoon, and wishing you all the best with your pre-calc.